Nintendo Switch. Let me show you what's going on. Rule number one, we always look at the port first. It's a little abused, but I believe it's structurally sound enough to do testing. Let's plug it up and see what it's doing. And we're getting nothing but a 0.08 draw. Let's see what it's doing on the OEM charger. Well, it recognized it for a second. Yeah, it jumps up to 3 volts and then immediately dies. So we definitely have a no power situation. This one we're going to have to take apart, at least enough to do some initial testing and see what's going on. These are common fault testing zones on side B, which is the side that is visible once you crack open the Nintendo Switch. We'll start our testing around the M92236, work our way down to the MOSFETs and test pads, and then over to the BQ24183 and see if we can find a fault. Let's begin our testing around the M92236, and we're going to be testing the capacitors that surround the chip, but the first capacitor we're going to test is actually connected to the Pi 3 USB on the back. The lines we are concerned about are the lines going to the chips. Alright, that one seems fine. Now we're going to check the rest of the capacitors. Same deal, lines going to the chips. Okay, we're getting a short on this line right here. We should not be getting a short on this line. We're getting a short on this line here. And we're getting a short on this line here. That chip seems to be very shorted. Let's check the rest of the capacitors. This capacitor is an exception. It has 2 lines going to the chip. In that case, only one side should be ground. Alright, the rest of them are checking out. Let's move up the board to our MOSFETs and test pads. We don't want any of those to be shorted. Let's check our little filter. We want continuity going through the filter to the chip, but not side to side. Check our invincible fuse. Our invincible fuse is still being invincible. Now we're going to check these test pads. None of these test pads in this area should have a pathway to ground. However, this one does. Now we know from past experience, this one is actually connected to the M92T36, which makes sense. It is shorted on the line. Sometimes it's the only thing that goes short and is the only thing that'll tell you that the chip is bad. Continue our testing. Make sure we don't have any additional problems. This coil should not have a pathway to ground. It does not. But it should have continuity going through it. It does. These test pads should not have a pathway to ground. They do not. The same rules apply for the BQ24183 as the M92T36, except that it has multiple capacitors with multiple lines going to the chip. I just generally know which ones to test now. Everything else seems to be okay. We know we definitely have an M92T36 issue, so we're going to have to disassemble it entirely, pull the board, and change out that chip and see if we can fix this problem. With your hot air set at 130, we'll heat these foam pads, and it's usually enough to get the adhesive to release, as long as it isn't terribly old. If it's old, there's really not much you can do. It's going to tear like so. Safest way to remove this cable. The first thing to know about this cable is never flick it out of the connector. The safest way to remove it is just to nudge the ears back and slide it out gently. While we have it out of the housing, we might as well check side A and make sure there's no additional issues. So we're going to check around the Pi 3 USB and the filters below the chip. Same rules apply on the Pi 3 USB as the M92T36 and the BQ24183, except we're just checking one capacitor here, this big one, and the line we don't want shorted to ground is the one going to the chip, and it's fine. Now we're going to check all these filters. We want none of them to be shorted to ground. And I'm detecting no shorts there. We do want continuity going through them though. Alright, everything's checking out. We do not want continuity going side to side. And everything's looking good. It doesn't mean it is good, but it's testing out okay. We're set up to remove our chip, but before I can remove my chip, we must turn on our equipment. And while I turn on my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. For your orientation purposes, the board view is on the screen. The target area is where we'll be working. Let's add some flux. Flux can also be found in the description under consumables. We'll remove our chip. Then we'll test and make sure our shorts have disappeared. When removing one of these chips, you just want to wait until you see visual evidence that every pin has wetted. There's no reason to even put your tweezers on the chip before that point. Successfully removed. Let's check and make sure those caps are no longer shorted. And everything looks good. Head down the board and check that test pad again. And it is no longer shorted either. Excellent. Now we're going to add a little bit more flux. Just a little bit. Grab our chip in proper orientation. And we're going to re-wet this solder. What we're looking for here is that center pad to wet. Now be patient. Don't worry too much about overheating the board. It can take quite a bit. Okay, the center pad is wetted. We want to make sure it has grabbed the chip before we release it. Center up. Remove your heat. Let it tack down. Then place some gentle downward pressure. And re-wet. And press it flat to the board. Remove your heat. Hold it down. And let it dry. We'll apply some flux so we can do some cleanup. For the cleanup, I'll use my Pico pencil. Excellent. Our soldering looks pretty good. Good on the side near the shield. Side facing the port is a little off, but everything is connected. I think we'll be fine. I hope you're getting value out of this video. Just a reminder, if you find you're not ready to tackle this, I do offer these services, both locally and mail-in. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. If you mention this video, I'll give you 10% off on your repair. Okay, before we get too excited, let's do some testing. The last lot of M92T36s I bought, almost the entire lot came up bad. We definitely need to test and make sure this brand new lot I just ordered is not coming up with the same results. Let's see if we're communicating on both sides. We'll plug in our OEM charger and we are drawing 14.9 15 volts on that side. That means it is communicating with the M92T36. We're going to flip it over. And we're getting 14.9 on the other side. So it is communicating with the M92T36 and charging on both sides. Excellent. The next test I want to perform is with our modified iPhone Power Squid, which we have retrofitted with Nintendo Switch connectors and Nintendo Switch Lite. We're watching PSU channel 1. We will activate the switch using our OEM charger. Just a real quick plug in and plug out. What we want to see here is just a steady climb in amperage. No hanging. Now using the OEM dock, we're going to test and see if it's docking. And it is docking. Excellent news. Now I have changed my testing routine. I was using this to test outside of the housing. Unfortunately, I've run into 2 cases where a Nintendo Switch actually docked on this dongle but wouldn't dock on an OEM, and I had to warranty a couple of switches. So unfortunately, while useful, this guy is not as reliable as I had hoped. I bought an extension for the OEM dock and we're using that, and I will start putting that in the description. Next step is to put it back in the housing and test from there. I just have it charging right now. As you can see, it's already booted up and we are drawing 15 volts at 1 amp. That is fast charging. So we're going to let it charge up for a little bit and we'll come back and test. We're up to about 14% now, and I just want to check and make sure everything is happy. We are charging the Joy-Cons. It is charging at 15 volts, 1 amp still. Just want to check and make sure we're getting Bluetooth, and we are. Excellent. Make sure we're picking up internet, and we are. it is recognizing their game. I think it's safe to button it up and reassemble it entirely, and I'll just let it charge, and we'll come back once it's fully charged and show that it's fully charged. Go from there. It's hours later, and it's back up and running. It's at 97% because I took it off the charger just to time how long it was taking for it to lose percentages. About 4 minutes just sitting idle, which seems relatively normal. I think we're good to go. If you got value out of this video, I think you'll get value out of this one, and I'll see you there. Until then, peace, love, and solder wing.